one here, okay, makakita ra ba mo? Wala i-zoom klasa. Okay, so for this one here, we have VC1, VC2. We have our two output. Okay, we have our transistor Q1, transistor Q2. We have the input voltage 1 and input voltage 2. Now in here, katong giingon ni engineer ka, na IT is just our IE. Main I, oops, sorry. Okay. Okay, this is just the IE-CAS. Nganong gitawag siya og tail current? Because having our VE here, right? Natay VE diri. Naatay IE moagi diri, naputay IE moagi diri. Right? And then, muusa na sila pagka-IE diri. Dinhi, mo ni siya ang IE1. In here, this is IE2. Kasabot ra ba? Okay, that one is our IE1 and that is our IE2. Now, the moment it goes down to our RE or the emitter resistor, then diha na to siya gitawag og tail current. Okay, so another, back to naming a, what do you call this, a differential amplifier. Okay, this is called differential input, differential output. Means nga nang gitawag man siya differential input, differential output. Now looking at the input, okay, kung duha gani siya din hikas, oops, duha gani siya ka input, you can see this one, right? There's an input voltage. There's also an input voltage. We are dealing or we are talking about differential amplifier. Mayroon itang differential amplifier, then there's input na pwede nimo ma-differentiate from each other. Pwede nimo kag-difference. In here, this is called differential input, differential output. Ngano, there are two outputs here. Okay? There are two outputs. Kasabot. Nganong gitawag siyang differential input, differential output. Kasabot ra ba
Yes,
class?
miss.
Yes, ma'am.
Yes.
Okay. Wait a second. And in there, you can see, um, hold on. Okay. You can see also there, we have our differential input. Okay. Atong differential input class, it has a formula of our output voltage equal to our voltage gain times V1 minus V2. And our V output for the differential output is V sub VC2 minus VC1 because our output here naaman siya sa atong VC1 napod sa atong VC2. For our input, okay, naa siya sa V1 napod siya sa V2. But there is differential nilang duha because nagtuyok naman na ang atong input. Ang output, output na lang na siya. Okay? Si input moagi pa mo na siya og mga processes inside that transistor o inside that differential amplifier. So you need to have that average voltage gain V1 minus V2. Next, which part? Which part pa man mo wala maka um what do you call this? Wala maka-catch up kayo. I have another picture here. Okay. from the um, video. Now this one here is called differential input single-ended output. Kakita mo, giunsa na ko pag name.
Yes, miss.
Okay, we have two inputs here, and we only have one single. So this is called differential input. Okay, we have two inputs, so that's differential. Differential input, single-ended output. But what if duha ang atong output pero usar ang input? So this is single-ended input differential output. Okay? What if usara atong input, usara po ang atong output? Kanir atong output. Then this is called single-ended input, single-ended output. Kakuha mo sa idea on how to name the amplifier.
Yes, miss.
Mm-hmm.
Okay. May tapos part. Important. Okay, this one. Okay. For this one, we have non-inverting input and non-inverting single-ended input, and we have the differential output wherein ang atong V output is just equal to voltage gain times V1. Miss, ngano, di ba ganina ang atuhang formula is V output is equal to voltage gain equals V1 minus V2 because we only have single input. Kung duha ka mo ka input, then minus ang duha ka input. Okay? Now in here, we only have sa panganay amplifier.
Single-ended input, miss.
And then,
Differential output.
okay, good. So this is single-ended input differential output. So si input, which is ang mugawa sa itong input nga Vout is a certain value of a voltage gain times our V1 because we don't have V2. Okay. Now for the non-inverting input, non-inverting single-ended input and single-ended output, we still have a certain value of our voltage gain times V1, right? So but our AV is half as much because we only have one output. Okay, this one. That one is non-inverting. For this one, oops, bakit nagyapon mo sa akong note? Mm. Okay, so from non-inverting, arita sa inverting. Ang inverting class is just your um ang imong output is 180 degrees out of phase from your input. So we have from inverting input, okay, inverting single-ended input and differential output. So atong V out is just the same here, but we don't have a voltage input for our V1. It's on V2, okay? And the negative sign, it denotes the inverted phase. Okay, in here we have inverting single-ended input and single-ended output. It's the same here, but we're not using V1, we are using V2. And it's negative because it is inverting phase. And the voltage gain will be half as much compared to our differential output because it is single-ended output. Okay. Now in here, okay, so for the DC analysis of a differential amplifier, as I've mentioned kanina, we have tail current, right? And ang pagkuha sa atong tail current kuno is the VEE minus RE. And that part is, ano na eh? Okay, so for that part class, iyang gi-treat si transistor as an in di ay sayo in ideal approximation. Who can give me the three approximation of our transistor? Unsa man to siyang mga approximation?
Katong ideal real og kuan miss. Kaya mo ko sa
Yeah, that's right. Now for ideal, ang gibuhat ni Ma'am Kath dali or Engineer Kath for the DC analysis of a differential amplifier, this one here is iyang gitreat ang transistor na yun. Iyang gitreat ang usa ka yes, the transistor as a switch only. Okay, so tail current is just equal to our VEE divided by RE, right? Ira jongi Ohm's law. Now we have emitter current, that's IE, right? But as I've said earlier, IE flowing here and IE flowing here, oops, is just equal. Okay, because our Q1 and Q2 are just similar if we are looking at a good designed amplifier. So, ikabot diri, IT na siya, right? IT na. But atong IE here and IE here is equal. So, therefore, i-add nilang duha is equals to IT. Now, in getting the IE, imo na i-divide si IT og kaduha. In getting IT, you just need to add the IE here, IE1 and IE2. Right? Para makuha nimo si IT. That if dili mismatch ang atoang transistor. But if our transistor is in good, this is um, made properly, matched properly, then you can have IE1 equal to IE2. Now our DC voltage collector, that's our VC. That's the voltage drop of our collector terminal to our to the ground, right? So we have here, unsang pagkuha, unsang pagloop, right? We can loop here. Naman si VC dire, right? So that's VCC minus IC because na IC mo agi dire, IC RC minus VC to 0 because voltage drop of our collector terminal down to ground. Okay, si VC man natong ipahita. So it's just VCC minus IC RC. Muna siya gikuha diri. Now for the second one, the second approximation is nanatay VBE. The the diode kung sa diode pa no, sa diode magud ako naman. If it's on second approximation, it is treated as a switch with a threshold voltage or a potential difference, diba? So in here, it's just really the same class. Oh, tanaw ninyo. VEE over RE. But for a second approximation, na may 0.7. 0.7 is the voltage drop between or it's the voltage drop from our base terminal down to our emitter terminal. So that's 0.7. Right? Unsang pagkuha si IT. Okay? Moagi ta diri. So that's this is VB1 here. Okay? That's VB1. Okay? VB1 man diri, di ba? VB1. Okay? But in solving that, that's VB1 minus VBE. Okay? Paano naman siya? VBE minus IERE. Okay? But ang IE diri is IT siya based sa discussion ni Engineer ka. Okay? Minus or that's plus because 'di ba kani siya is naka-circle. If I do that on an ideal symbol, so that's Yan, igawa siya sa positive. So that's positive VEE equal to 0. So VB1 is just directly corrected to the ground in this sketch, okay, in this diagram. So as is na siya nga 0. So we only have VEE minus VBE auto a transpose C IE because we need to find IE or IT, the tail current. So that's IERE. Divide both sides by RE para makuha si IE. Right? So, diha gikuha si IT. VEE minus VPE divided by RE. Muna siya nga formula. It's the same as our electronics. Kinamdong pa mo ba na? Class? Hello? Am I still?
Yes, ma'am.
Okay. So, in this part, the effect of base resistors, okay? Si base here, if na ay resistor si base, okay? In here, this is the base. This is collector, this is emitter, and the base, right? CBE. So, if naatay bias resistor diya sa atong base, then mo ni siya ato ang formula. But ang giingon ni Miss Kat is kanang base resistor diya is very very minimal lang ang epekto with regards to the beta. So pwede ra jud nga neglect ni siya diri. Okay, this is just less than 1% of our calculation. So pwede ra jud na siya ma-neglect. So ang mahabilin is this one, which is just this one here. Okay, muna siya gimin ni Engineer kanina. So far, nakasabot ra ba?
Yes, miss.
Okay. Okay, na siya gihatag nga example problem. Sa example problem, nakakuha ra ba mo? I want you to be honest para ma-discuss ako balik. Tingog lang mo class kayo. Ako katanaw sa meet if ever na ay ni thumbs up, thumbs down, or comment. Ay, how about the others? Yes or no dito ba?
No, ma'am. No nga kapital.
No? Okay, okay. Hold on. Okay, so we have here a differential amp. Okay, we had two transistors. We have 15 volts as our VCC. We have RC1. We have RC, both RC nato is 5 kilo ohms. We also have um a 7.5 kilo ohms ng RE and a VEE of negative 15 volts. Now, during an ideal approximation, okay, ideal approximation, we need to find IT. IT can be found using VEE divided by RE. Ano sa mga itong VEE? VEE.
15 volts, Smith.
Yes, that's 15. Okay, so that's 15 volts divided by our RE is 7.5 kilo ohms. So this is
2
2.2.
milliampere.
Okay, this is 2 milliamperes. Next is we need to find IE. Now remember IE, IE1, IE2, IE2. Here, equal ra na sila. Okay? Because atong gi-assume nga maayo pagkahimo o maayo pagka-design ato ang amplifier. They are match. Okay? Since IE1 and IE2 is equal, therefore, it's just IT divided by 2. Same sa akong explain kanina. So, IE1, IE2, that's 2 milliamperes divided by 2. So, that's 1 milliampere. Okay? Now, we need to find VC. Okay? Define man ni VC diri. Unsa ang pagpangita ni VC?
Loop, miss.
Loop. Okay. Hold on. Okay. Now you need to do V. Okay. VC is just VCC minus IC RC. That we have two VC here. Oh, there. Okay. So if VC1 is equal to VC2, again, we assume na to is perfect, good siya nga pagka-design. So it's just VCC, VCC minus IC, RC. So VCC is 15. We have IC, din pa po ang IC. IC is just equal to our IE, right? Remember mo? IE is equals to our IC. Miss, nga no miss, remember, IB, right? IB is very, very small. Nga, pwede na nato man na siya man-neglect. So, ang makabili na lang is IE equal to IC. So, atong IC is equals to IE. So, that's just 1 milliampere times our RC at 5K. Okay, so this is 10. 1 milliampere times 5K is 5. 15 minus 5 is 10. So this is 10 volts. So VC1, which is equals to VC2, is equal to 10 volts. Follow.
Yes,
Yes,
ma'am.
miss.
Okay, now going to the second approximation. Second approximation is the real, right? It is treated as a switch with a voltage. Okay, so in here, ang pagkuha sa tong IT is IE or IT is VEE minus VBE divided by RE. Now VEE is 15, VBE is 0.7, RE is sayo. Pasok ko ba? Pasok to lang. 7.5. Okay. Okay. Pila na siya everyone. Wala ko'y calculate.
1.91 milliampere, miss.
Okay, 1.91 milliamperes. Next, we need to find IE, both IE1 and IE2. It's the same given nga second approximation siya. You just really need to follow IT divided by 2. IT is 1.91 divided by 2. Palag ko everyone.
0.955 milliampere, miss.
Okay, thank you. 0.955 milliamperes. Okay, that's how you solve IE, both IE1 and IE2. Now for our VC, okay, CVC, pareha hapon. VC1, VC2, VCC minus ICRC. VCC is 15 minus IC is just equal to our IE. So that's 0.955 milliamperes times RC, which is 5K. Well, here go everyone.
10.025 volts, miss.
10.025 volts. Okay. Now using the ideal, this is the ideal one, and this is the real one, or the second approximation. That's how you find the um, current bias and the voltage bias. Nga gipangita. The tail current, the IE, both of the IE, and also our VC, VC1 and VC2. Nakasabuat.
Yes, miss.
Yes, miss.
Okay. Now for AC analysis of a differential amplifier, how about this one? Paste it here. Okay. How about this one? AC analysis. Okay, now in AC analysis, we have non-inverting, okay, non-inverting, single-ended input, single-ended output. Okay, if our voltage here has in a waveform of this one, we have our VE of a smaller waveform compared to this one, and a very large output in our V out. Okay, matod pa ni Engineer Kat, the two halves of a differential amplifier respond in a complementary manner to the non-inverting input. Q1 acts like an emitter follower that produces an AC voltage across the emitter resistor. The amplified output sine wave is in phase with the non-inverting input. Unsay meaning ana, miss? Okay, so if we have di lang ako siya ibutang sine. If we have input waveform in here, okay, at positive half cycle, okay, tara mo sa akong arrow as
Yes, ma'am.
Yes, miss.
Kita na, ma'am.
okay. If ang kani siyang output voltage niagi na siya sa positive cycle, then there is a positive voltage. Okay? So positive na siya, dako ang moagi diri nga voltahe or signal, right? Dako signal moagi diri. Now, ang gingan ni Engineer Cut is it responds in a complementary manner. So kung dako ang moagi diri nga signal, dapat ang moagi diri nga signal is gamay para balanse silang duha. Okay? So if there's a um, good positive value here and in positive cycle, I mean, dapat gamay ang mahitabo dire sa ato ang Q2. Okay? Now, if gamay ang atong IE dire, right? Kung gamay atong kuryente or signal mo agi dire, di ba dire dapat dako? Kung dire gamay. Now, if IE nato dire is gamay, remember, IE is equal to our IC. Right? Kung si IE gamay, IC is gamay. Alright? Now, the moment you make a loop, the moment nga i-trigger diri, mo trigger po siya diri because this is another voltage input. Okay? Sa ato ang amplifier. Okay? Iyahan ni siya. Okay? The moment a voltage flows here and gamay ang atong IC, okay? Dako ang atong voltahe. Right? Kay gamay man ni siya diri, in complementary manner man siya. Isod nimo diri, dako. Complementary manner, so dapat gamay si IE. Now, once mo gamay si IE, gamay po si IC because they are equal to each other. Dili jud siya tantong equal because we have a small difference because of IB, but it can be negligible. So, IE is just equals to IC. Kung si VCC, muagi na diri, together with the triggered, okay, small signal here, pun diri, so we have a amplified output. Kuha ba class? Kuha nga nung kakuha mo nga sa akong explanation.
Yes,
Are you
miss.
still there? Oh, okay. Okay. So this is why nganong gitawag siya og non-inverting. Kay it at possible half cycle diri possible at positive half cycle diri nag-positive half cycle po siya. Okay? Muna siya non-inverting. The input and output is 180-degree in phase of each other. Kuha. Okay. Now, if we do inverting, okay, kung si inverting, the same process. Okay? Hold on. Okay. So that's why it's called non-inverting. If kung ang tawagon siya inverting class kung ang atong input at positive half cycle igabot niya sa output it is on negative half cycle, then that's the time nga it's called inverting. Okay? So going forward, uh, it's already 12 in my clock. When is our
Same.
next meeting gani? Thursday, tarong Tuesday, right?
Yes, ma'am.
Thursday. Thursday, mixed signals kaya punta. Thursday, Thursday. 9 to 12 still, right?
Yes, ma'am.
Okay, so let's just continue it on Thursday. So hopefully, na may nasabtan sa akong i-discuss. Og sa video nga inyong gitan-aw. Nakasabot ramang ka mo.
Yes, ma'am.
Okay. Do you have questions before I